Before watching this video, please make sure that you have already watched 3 lectures that I have uploaded on this chapter parabola. So now the next theorem is, if the coordinates of the ends of a focal chord of the parabola y square equals to 4ax are x1, y1, x2, y2, then prove that x1, x2 is equals to a square, y1, y2 equals to minus 4a square. And for a focal chord PQ of the parabola y square equals to 4ax, if SP is equals to L, SQ is equals to L dash, then prove that 1 by L plus 1 by L dash equals to 1 by A. Let us suppose that this is the parabola. This is y square equals to 4ax parabola, and this is focus S, and this is my principal axis, and let us suppose that this is the chord. PQ is the chord, and for the parabola y square equals to 4x, yes, a comma 0 is the focus. This is P x1 y1 and Q x2 y2. Here S focus, P comma Q, the ends of the focal chord, all are lying on the same line. Therefore, P, S, Q are collinear points. So here, let S a comma 0 be the focus of the parabola y square equals to 4ax, and P equals to P x1 y1 and P x1 y1, Q x2 y2 are the ends of the focal chord. So since x1 y1 x2 y2 are the ends of the chord, so the parametric point of P x1 y1 is a t1 square comma 2a t1, and this is a t2 square comma 2a t2. So here S, P, Q are lying on the same line, are collinear points. P x1 y1 is the Cartesian point, while a t1 square comma 2a t1 is called the parametric point. So let us take a t1 square comma 2a t1, a t2 square comma 2a t2 with the ends of the focal chord. So SPQ are collinear points. Now the slope of SP equals to slope of SQ. Slope of SP is equals to slope of SQ. What is the slope? Difference of ordinates by difference of abscissa. So here 281 minus 0 by this is x1 y1, this is x2 y2. So y2 minus y1 by x2 minus x1, a t1 square minus a. This is equals to what is the slope of SQ? 2a t2 minus 0 by a t2 square minus a. This is equals to 2a t1 by, if I take a in common here, t1 square minus 1 is equals to 2a t2 by a, if I take common, t2 square minus 1. So this is equals to, so 2a gets cancelled, here a gets cancelled. So t1 into t2 square minus 1 is equals to t2 into t1 square minus 1. This is equals to t1 t2 square minus t1, t2 t1 square minus t2. This is t1 t2 square minus t2 t1 square minus t1 plus t2 equals to 0. This is t1 t2, if I take common, then here this is t2 minus t1 minus 1 into t1 minus this is plus 1 into T2 minus T1 equals to 0. So take T2 minus T1 common, then we get T1 T2 plus 1 equals to 0. So from this T2 minus T1 equals to 0, T1 equals to T2. Therefore, since these 2 points are not equal, so it has to be equal. So T1 T2 plus 1 equals to 0, T1 T2 equals to minus 1 is the required condition. So from this, what is T2? T2 is equals to minus 1 by T1. Now, what is x1, x2 now? Consider this is to be proved, x1, x2 equals to a square. Now consider x1, x2. What is x1, x2? at1 square. x1 is at1 square. x2 is at2 square. This is a into a square. T1 square into T2 square is T1 T2 whole square. This is equals to a square. T1 T2 is what? Minus 1 we get. So therefore x1 x2 is equals to a square. And consider y1 y2 now. What is y1? 281. This is x1 y1 and this is x2 y2. So y1 y2 is 281 into 2a t2. This is equals to 2a into 2a, 4a square t1 t2. So 4a square t1 t2 value is minus 1. Therefore this is minus 4a square. So x1 x2 is equals to a square and y1 y2 equals to minus 4a square. And one more thing that we can reduce is, see here, t1 t2 equals to minus 1. Substitute in this. Then q x2 y2 is equals to q x2 y2 is x2 is a t2 square. A, what is t2? Minus 1 by t1. x2 y2 is a t2 square 2a t2. So a t2 is minus 1 by t1. So minus 1 by t1 whole square, comma 2a t2 value is minus 1 by t1. This is equals to minus 1 by t1 square is a by t1 square. This is minus 2a by t1. That means if p comma q are the ends of the focal chord, then p is equals to a t square comma 2at and q is a by t square comma minus 2a by t. So t1 and t1, so I have generalized with the t. Then p is a t square comma 2at and q is equals to a by t square comma minus 2a by t. And one more, this is to be proved at. So now sp is equals to L, this is L, and sq is equals to L dash. Then we need to prove that 1 by L plus 1 by L dash equals to 1 by A. So what is L? L is sp. That is square root of a t1 square minus a t1 square. Distance formula x1 y1 and x2 y2. x1 y1 and this is x2 y2. So square root of x2 minus x1 whole square plus y2 minus y1 whole square. A t1 square minus a whole square plus 2a t1 minus 0 whole square. This is equals to, if I take a in common in both of them, this is t1 square minus 1 whole square plus 4a square t1 square. So this is, if I take a square in common in both of them and take from the root, then actually we will be getting a into square root of t1 square minus 1 whole square plus 4t1 square. This is equals to a into, this is a minus b whole square, t1 square whole square, t1 square whole square is t1 power 4 plus 1 minus 2t1 square plus 4t1 square. This is t1 power 4 plus 4t1 square minus 2t1 square. This is 2t1 square plus 1. So this is t1 square plus 1 whole square. So this is equals to a into t1 square plus 1. And what is L dash? L dash is S cube. So the same at1 square, this is how much? at2 square comma 2at2, right? So then actually the same everything we will be getting until we reach a into t2 square plus 1. Now L minus a into L dash minus a I will take. What is L? L is this a into t1 square plus 1. L is t1 square plus 1 minus a into L dash minus a is a into t2 square plus 1. What is L dash? L dash is a into t2 square plus 1 minus a. So this is equals to a t1 square, a into 1 a minus a cancel. So a t1 square is what I am getting here into a t2 square plus a minus a. Cancel a t2 square, I am left with a t2 square. So this is equals to L minus a into L dash minus a is equals to a into a square. This is t1 t2 whole square. So this implies L into L dash minus L into a minus a into L dash a minus into minus plus a square is equals to a square into t1 t2 value is t1 t2 is minus 1 we get. Minus 1 whole square is 1 into a square. A square gets cancelled. L dash minus, if I take a in both of them, then we will be getting L plus L dash equals to 0. So from this, L dash is equals to a into L plus L dash. From this, 1 by a is equals to L plus L dash by L dash. Therefore, L by L dash is L gets cancelled 1 by L dash. L dash by L dash. L dash cancel 1 by L. Therefore, 1 by L plus 1 by L dash is equals to 1 by A is what we need to prove. Find the equation of the parabola whose lateral rectum is the line segment joining the points. So, let us suppose that this is the parabola. So, minus 3 comma 2 and minus 3 comma 1. So, here minus 3 comma 2 is this. And minus 3 comma 1 is this. Okay. This is minus 3 comma 1 and this is minus 3 comma 2. These are the ends of the lateral rectum. That means based on this the parabola could be, and what is the midpoint here? This is L dash. This is S. So solution, let L minus 3 comma 1, L dash minus 3 comma 2 or be the ends of the lattice rectum. Ends of the lattice rectum. S is the midpoint of L dash, that is equals to minus 3 by 2, x1 plus x2 by 2, y1 plus y2 by 2, 1 plus 2 by 2. This is minus 6 by 2, which is minus 3, comma this is 3 by 2. Now, equation of the lattice rectum is equals to, what is the equation of the lattice rectum? So y minus y1 by y2 minus y minus y1 is equals to y2 minus y1 by x2 minus x1 into x minus x1, or simply this is x equals to minus 3. This is a line parallel to y-axis is of the form x equals to something. So this is x equals to minus 3 line. Otherwise this is x plus 3 equals to 0. Now the parabola could be, this is the principal axis. This is the principal axis, and based on the principal axis, the parabola could be like this, or the parabola could be like this. So there would be two parabolas possible based on the lattice rectum L dash. Now, equation of the, so for the convenience, for example, let us take the parabola be this, then this is the principal axis, and this is y-axis, and this is directrix. Okay, this is the directrix. So equation of the directrix. So the directrix is parallel to the lattice rectum. Equation of the lattice rectum. So equation of the directrix, which is parallel to the lattice rectum, is of the form x equals to k. See, this is x equals to 3. The directrix is of the form x equals to k. Now, this is x equals to k is the equation of this lattice rectum. Now, this is minus 3 comma 3 by 2. So that means x minus k equals to 0. So now so here the distance of a point S with respect to the directrix is the perpendicular distance from this point S to the line L. So now the perpendicular distance or length of the perpendicular from S, length of the perpendicular from S3 comma 2 to x minus k equals to 0 is modulus 3 minus k by square root of 1 square plus 0 square. So this is 3 minus k modulus. So that means from this to this is 3 minus k. What is this? 3 minus k. Okay. So That is, the shifting of origin has taken place. That is why I have dropped the x-axis like this. So now, so from this to here, so what is SL? The total distance is LL dash is equals to 4A. The length of the lattice rectum is 4A. SL is the length of the semi lattice rectum. That is 2A. This is totally 4A. This is 2A. This is 2A. So SL is equals to 2A. And the distance from this to this is how much? The distance, this is A and this is A. So totally, let us suppose this is Z. Okay. So this is SL is equals to 2A and that is equals to SZ also. Length of, this is equals to length of, why SZ is equals to 2A? Because this is the vertex of this parabola. So vertex, focus, foot of the directrix, all are lying on the same line, collinear points. Therefore, so SA is equals to A, ZA is equals to A. This is 2A. This 2A is equals to this 2A. So length of SZ. So this is equals to 3 minus K is equals to, so this is 3 minus K and SL is equals to how much? Of SZ. Minus 3 plus 3 whole square plus 3 by 2 minus 1 whole square. This is equals to 0. This is square root of 3 minus 2 ones are 2 by 2 whole square. This is 3 minus 2, 1 square. This is 1 by 4 totally. So that is 1 by 2. So modulus means plus or minus. So from this, 3 minus K is equals to plus or minus 1 by 2. From this, 3 minus K is equals to plus 1 by 2. So that is 3 minus 1 by 2 is equals to K. So 2 3s are 6 minus 1, 5. So K is equals to 5 by 2. Or 3 minus K is equals to minus half. So 3 plus half is equals to K. So 2 3s are, so therefore K is equals to 7 by 2. Therefore the equation of this directrix is X minus 5 by 2 equals to 0 or X minus 7 by 2 equals to 0. So we have got the K values 5 by 2 and 7 by 2. So substitute back in the equation of the directrix, which is which is parallel to LN dash. Therefore, X plus 5 by 2 equals to 0, X plus 7 by 2 equals to 0. Let Px1 will be any point in the parabola. So that means let us take P any point on the parabola. So according to the definition of a parabola, SP is equals to PM. What is this M? M is a point. M is a point on the parabola which is perpendicular to P onto the directrix. So by definition, SP square is equals to PM square. So SP is, so x1 minus of minus. So x1 plus 3 whole square. X1 plus 3 whole square plus y1 minus 3 by 2 whole square is equals to PM. So first of all, case 1 if I take, case 1, so x plus 5 by 2 equals to 0 we will take. That means, so this is x plus 5 by 2 equals to 0. Now, what is PM? The length of the perpendicular P x1 y1 to the line x plus 5 by 2 equals to 0. That means x1 plus 5 by 2. x1 plus 5 by 2. PM by square root of 1 square. So PM square is this square. So there are two cases arises. One, the directrix x plus 5 by 2 equals to 0 we will take, and the next x plus 7 by 2 equals to 0 we will take. So this is equals to x1 plus 3 whole square plus 2y1 minus 3 by whole square by 2 square is 4 is equals to, this is 2x1 plus 5 whole square by 2 square, this is 4. This is LCM. If you take 4 into x1 plus 3 whole square plus 2y1 minus 3 whole square is equals to 2x1 plus 5 whole square. So throughout the equation, 4 on both the sides of in the denominator gets cancelled. So this is 2 into y1 minus 3 whole square is equals to 2x1 plus 5 whole square minus 4 into x1 plus 3 whole square. This is 4x1 square 2 into. So 4x1 square, 5 5s are 25 plus 5 2s are 10 2s are 20x1 minus 4 into, this is x1 square, 3 square 9 plus 2 3s are 6x1. This is equals to 4x1 square gets cancelled. This is 20x1 minus 4 6 are minus 24 plus 20 minus 4x1. This is 25, 4 9s are 36. 25 minus 4 9s are 36 minus 36 25. So 1, this is minus 11. So this is minus 11 is equals to 2y1 minus 3 whole square. So this is equals to, if I take minus as a common here, plus therefore the locus of P x1 y1 is 2y minus 3 whole square is equals to minus of 4x plus 11. So still the problem is there. So for x plus 5 by 2 is equals to 0, directrix we have taken, and for x plus 7 by 2 is equals to 0 also we need to take. So the second case, x plus 7 by 2 equals to 0 is the directrix now. Let Px1 y will be any point in the parabola. Equation of the parabola having minus 3 comma 3 to be the focus, and directrix is x plus 7 by 2 equals to 0. Last case we have taken x plus 5 by 2 equals to 0. So in the place of 5 by 2 I changed 7 by 2 here. So this is 2x plus 7 by 2 square, that is 4. LCM I have taken, and I have simplified 2y minus 3 whole square, I kept it intact. 2x plus 7 whole square, this I have transposed and simplified. Then I get 2y minus 3 whole square equals to 4x1 plus 13. Therefore the locus of Px1 y1 is 2y minus 3 whole square equals to 4x plus 13. The next problem is find the position between exterior, interior or on of the following with respect to the parabola. 3 points are given. So we have discussed the position of a point with respect to parabola is simply substituting x1 y1 in the parabola. That is S11. If S11 is equals to 0, a point lies on the parabola. If S11 less than 0, point lies interior of the parabola. That is focus side. If S11 greater than 0, then the point lies outside the parabola. So now, so given parabola is y square minus 6x1 s. Now first point is substituting 6 comma minus 6 implies 6 square 36 minus 6 into x1 value is minus 6. So y square is minus 6 whole square, that is plus 36, minus 6 into x1 value is plus 6. This is 36 minus 36, 0. Therefore, 6 comma minus 6 lies on the parabola. On the parabola is equals to 0. 0 comma 1. Substituting 0 comma 1 we get. So here y square is 1 square minus 6 into x1 is 0. So this is 1 which is greater than 0. So if s11 greater than 0, point lies outside the parabola. So 0 comma 1 lies outside or exterior of s equals to 0. And third one is 2 comma 3, substituting 2 comma 3. That implies 3 square 9 minus 6 into 2, 6 2s are 18, which is minus 9 less than 0. Therefore, 2 comma 3 lies inside the parabola. That is the focus side of the parabola is equals to 0. Now, find the coordinates of the parabola y square equals to 8x whose focal distance is 10. So here focal distance is what? This is the parabola. This is focus S and this is for example P on the point lies on the parabola. So SP, the distance is x1 plus a modulus. This is the focal distance. Now find the coordinate of the parabola. Given parabola is y square equals to 8x. If you compare this with y square equals to 4ax, so 4a equals to 8. Therefore, a is equals to 8 by 4, which is 2. So now, the coordinates of the parabola whose focal distance is given focal distance is modulus of x1 plus a is equals to 10 given. That means x1 plus a is equals to plus or minus 10. x1 plus a is 2 is equals to plus or minus 10. This a is plus 2. If you take to that side, minus 10, minus 2. So if you take plus 10 minus 2 is 8. Or if you take minus 10, ten minus 2 is 8, minus 10 minus 2 is minus 12. So here substituting so here very first I will take x1 y1 on the parabola. Let p x1 y1 be a point on the parabola. If a point P lies on the parabola, point has to satisfy the parabolic equation. So y1 square is equals to 8x1. So that implies y1 square is equals to 8 into the value of x1 is 8. So that implies y1 square is equals to 64. y1 is equals to plus or minus 8. So therefore, find the coordinates of the parabola. That means plural sense. We will get more than one coordinate of the parabola. So one point is P is equals to x1 y1. So here 8 comma 8 and 8 comma minus 8. So minus 12 cannot be taken and substitute here because 8 into 12 is something negative. So y1 square cannot be negative. Therefore 8 comma 8 and 8 comma minus 8 are the coordinates of the parabola. If 1 by 2 comma 2 is one extremity of a focal chord of a parabola, y square equals to 8x. Find the coordinate of the other extremity. That means this is the parabola given. Y square equals to 8x. So given parabola is y square equals to 8x implies 4a equals to 8. Therefore, A is equals to 2. Now, focal chord of the parabola. So, let S be the focus and this P comma Q are the ends of the focal chord. So, we have discussed that if P AT square comma 2AT is one end of a focal chord then the other end is a by t square comma minus 2a by t, that we have discussed in this lecture itself. So T1, T2 equals to minus 1 is the condition for the focal chord. So T2 is equals to minus 1 by T1. Substitute back in Q. P is 81 square 281, Q 82 square comma 282. So substituting T2 is equals to minus 1 by T1, then these are what we get now. So given end of a focal chord B P a t square comma 2at, that is equals to 1 by 2 comma 2. So comparing with the x coordinates or y coordinates. So here 2at is equals to 2. So 2 gets cancelled. A value is 2. 2t is equals to 1. Therefore, t is equals to 1 by 2. Now, so therefore, the other end Q is how much? A by t square comma minus 2a by t. This is equals to A is 2 by t square is 1 by 2 whole square 1 by 4 comma minus 2a, minus 2 into a value is 2 by t value is 1 by 2. This is equals to 1 by 4 is 4. 4 2s are 8 comma minus 2 2s are 4 2s are 8. 8 comma minus 8 is another end of a focal chord. This is 1 by 2 comma 2.